All right, we're going to take a look at one of the special exponential functions that we're going to deal with, and this will take us into some logarithms eventually here too. And it's what we call a natural base e. Now in a way, it's kind of like when we had our value for pi. We obviously have a number that's going to go on forever, and we have to find a good way of writing this. So they named it e, and they call it the natural base e. So whenever we use our value here for e, it's approximately 2.718281828 and so on. So an irrational number that we're going to deal with, and when we put it in the form for an exponential function, anytime we use e for our base, we're going to call it our natural exponential function. Now, most of this, obviously, just by looking at the number, you can probably figure this out. We're going to be working on the calculator. Now, you're going to see two things depending on which calculator you're using. There's an e to the x and an ln x. Depending on the calculator you're using, either the enx is going to be on the button and the ln x is going to be above it, or you're going to see ln x on your button and the e raised to the x is going to be above it. Alright, so obviously if you've got this one, you know which button to push. If you have this one, you're most likely going to have to push either your shift key or your second key or whatever goes along with the calculator that you're dealing with to get to that value. Now again, each calculator kind of does its own thing as far as the order that it does things. So just to give you an idea so you can do a quick calculator check on yours and see which order yours would be, if we were asked to find e raised to the -2, it should come out approximately as 0.1353353. Let's try another one. If you were to get e raised to the -1, which is actually equal to 1 over e to the first, you should end up on this one getting approximately 0.3678794. And let's do one more as a decimal or a fraction. E raised to the 1/4. Now remember, if you plug this into your calculator, you're doing a fraction, or if it's a common fraction, you can probably ignore the parentheses by just typing in 0.25. So on this one, it's going to come out to be approximately 1.2840254. So my suggestion is, on your calculator, test each of these to see which order you want to put those in. And if you're not sure, talk to your teacher, and it's usually pretty simple to figure out. So that's something that you need to take a few minutes on. Test that, see how that button works on your calculator and which order you have to enter things. Alright, now one other thing is, we're going to get into the graph of e raised to the x power. Now one thing that we should look at here, we've already looked at saying that e is approximately 2.7182818, so. So obviously that number is bigger than 2 and it's smaller than 3. So if we were asked to graph this value and raise it to the x power, it should make sense that if I do this, 2 to the x should be smaller values, 3 to the x should give me bigger values. So now one thing that we remember when we looked back, when we did some of that graphing before, and this is going to be a real crude sketch really fast, if we did 2 to the x and got that, then when we went to 3 to the x, remember it ended up getting a little bit steeper, 4 to the x got a little bit steeper, and so on. So let's see what happens when we do e to the x. Since it comes between 2 and 3 for a value, we should expect that wherever our 2 to the x graph was and our 3 to the x graph was, e to the x should fall somewhere in between those two. So let's take a look and let's see if that actually is the case. Alright, so here we've got it set up for our 2 to the x. So let's plot that first. And there it is in red. And we'll do 3 to the x. And this one's going to be coming up in green. So 2 to the x is here, 3 to the x is here, and since we've got 2.71828, 1828, 1828 is always between 2 and 3, then if I type in e raised to the x power, I would expect that it should come out in between those two graphs. So let's look at the blue one here, and there it is. So comparing those, let's take a look again just so we can get them labeled so you can see this. The red graph again, and it's not jumping to my screen like I like. Now I think it'll go. The red graph that we see right here, that came from y equals 2 to the x, and it's just being a little ornery, so it's not really letting me write here, but we can still point it out. Our green one was 3 to the x, which, like we said, was steeper, faster, and again, 2.718281828 is pretty close to 3, so again, it should be steeper than what 2 was, but not quite as steep as what 3 was. So there is an actual graph for that value.